Open-weight model releases. South Korea has announced its presence in the open-weight AI arena with considerable force. Naver, the country's dominant internet company, released Hyperclova X Seed Think, a 32B reasoning model, alongside Hyperclova X Seed 8B Omni, a unified multimodal system handling text, vision, and speech in a single architecture. The Omni model has sparked particular interest in the local LLM community, though the burning question remains whether it can challenge Sesame's dominance in audio-to-audio generation, a benchmark that remarkably no open model has seriously threatened as 2025 closes out. But Naver's release was merely one salvo in what observers are calling a coordinated Korean offensive. The same period saw AXK1 590B MoE with 33B active parameters, VAETKI MoE with just 10B active, Solar Open 102B MoE trained on a staggering 19.7 trillion tokens, and LG's KXO1 at 236B with 256K context length. The economics are striking. This initial 5-model wave reportedly cost around $140 million using 1,000 B200 GPUs provided by the Korean government. With 260,000 GPUs now in procurement, 2026 promises to amplify this sovereign AI push considerably. The mixture of experts' architecture dominates these releases for good reason. Efficiency. VAETKI activates only 10B of its 112B parameters during inference, while employing multi-head latent attention and sliding window attention with a 512 token window. These aren't just paper tigers. They're engineered for practical deployment, trained largely on open data in what amounts to a principled stance on model accessibility. Meanwhile, AI2 continues its mission to democratize language model research with OMO3, releasing both 7B and 32B variants in Instruct and Think configurations. The release maintains AI2's characteristic transparency. All code, checkpoints, and training details are public. The models follow a multi-stage training pipeline, supervised fine-tuning, DPO alignment, and RLVR for final polish. Supported in Transformers 4.57. They're designed for immediate integration into existing workflows. Mistral's December proved equally productive. The company shipped Mistral Large 3, a frontier-grade multimodal model with 256K context, alongside the Mistral 3 family spanning 14B to 3B parameters for edge deployment, all under Apache 2.0. DevStral 2 followed a week later, targeting software engineering workflows, and Mistral OCR3 arrived mid-month for structured document processing. The velocity here signals Mistral's strategy, comprehensive coverage across the capability spectrum rather than a single flagship model. Meituan's Longcat video avatar represents a different frontier, unified audio-driven character animation supporting text-to-video, image-to-video, and video continuation modes. The technical approach addresses persistent problems in generated video. Disentangled unconditional guidance separates speech from motion dynamics, while reference skip attention prevents excessive identity leakage from conditioning images. Human evaluations on the EvalTalker benchmark, 400-plus samples, show competitive naturalness scores, though the compressed demonstration videos require independent verification. AI agent architecture and development tools. The question of what constitutes an agent continues to shape architectural decisions in meaningful ways. One developer building a QA bot for production monitoring, triggered after a deployment broke production, confronted this directly. The system monitors health checks, executes rollbacks on failure, attempts diagnosis and fixes, then either promotes solutions or escalates to humans. By Duke's proposed criteria, environmental impact, goal-directed behavior, state awareness, it qualifies as an agent. It literally modifies production systems. But the developer's key insight was architectural. Keep the trigger layer deterministic while constraining the LLM's reasoning to tight bounds. Triggers are predefined conditions, not emergent goals. This bounded autonomy pattern, dumb, predictable orchestration invoking agent-like behavior only when triggered, represents a pragmatic middle ground. I don't want software that surprises me at 3 a.m. captures the philosophy. The autonomy spectrum question becomes practical. Who holds commit rights? If the model can modify production without human gates, brutal invariance and thorough observability become non-negotiable. Research is formalizing these intuitions. BODE, Bandit Optimization for Agent Design, addresses why single-agent systems struggle with out-of-distribution problems. Forcing one agent to retain all context throughout problem-solving introduces spurious correlations. The paper's core hypothesis, that irrelevant context causes overfitting to training distributions, leads to a hierarchical solution. An orchestrator coordinates specialized subagents, each handling specific subtasks with only relevant information. The semi-MDP formulation treats subagents as temporally extended actions, reducing decision frequency and simplifying planning. This mirrors how human engineers decompose complex problems to manage cognitive load. On the tooling front, implementations are catching up to theory. An MCP server wrapping Andrej Karpathy's LLM Council project enables multi-LLM deliberation directly in Claude Desktop or VS Code. The three-stage process, individual responses, peer rankings, synthesis, now completes in roughly 60 seconds through a simple natural language request. HMLR, a newly released memory layer for agents, targets a different gap: long-term multi-hop reasoning and constraint enforcement across sessions. The system passes Hydra 9 hard mode, a 21-turn test requiring correct answers with full causal reasoning chains across 9 entity aliases and 8 policy updates, arriving in complete isolation. A more ambitious experiment trades inference speed for reasoning depth. One developer's recursive swarm engine forces exploration of 10,000 logic branches before committing to code. 20 minutes of compute for improved accuracy on complex problems. The community response was mixed, with some dismissing it as the sloppiest slop fest that's ever slopped. Whether the approach yields genuine improvements or merely inference cost inflation remains an open question requiring systematic evaluation. AI-assisted software development. A pattern emerges when maintainers discuss AI-assisted development. The tools accelerate code generation, but the bottlenecks were never really about typing speed. One open-source maintainer's 6-month retrospective using Claude Code crystallizes this. AI is a multiplier, not a leveler. The observation cuts to the heart of what AI changes and what it leaves untouched. Brooks' Mythical Man Month remains surprisingly relevant despite LLMs, not because of how code is produced, but because of what actually slows software down: coordination, shared understanding, and conceptual integrity. AI makes code cheap. It does not make software design, architecture, integration, or alignment free. In fact, faster code generation can amplify existing problems. Incoherent abstractions appear sooner, integration costs surface later, and we're almost done illusions become more convincing. The counter-argument deserves acknowledgement. Speed was absolutely a bottleneck for many startups. From Yahoo to Facebook, competitive advantage often came from shipping features faster than rivals. Now that AI democratizes rapid iteration, speed stops being a differentiator. But this just shifts the constraint. The modern leverage point isn't the fastest coder, but the person who frames problems well, guides AI output, and preserves system coherence. A modern version of Brooks' Law might read, adding more AI to a late or poorly defined project makes it confusing faster. What matters more than ever is strong architecture, clear intent, and technical leadership. The tooling accelerates implementation. It doesn't substitute for knowing what to build or why. If you don't understand what you're constructing, AI will only help you fail faster. The bottleneck has always been thinking, not typing. Section Performance Optimization and Infrastructure. Llama.cpp's latest optimization demonstrates how domain-specific knowledge can outperform general algorithms. Top K sampling on Llama 3's 128K vocabulary means finding the K highest scores among 128,256 candidates, traditionally O(n) log K with partial sorting. The insight: token logits cluster in a narrow range, typically -10 to +10. The implementation exploits this by building a 128-bucket histogram over the logit range, walking from the highest bucket down until accumulating K tokens, then sorting only those survivors. The result: 2.9x speedup in micro-benchmarks. However, context matters. The optimization triggers only for K128, while typical chat applications sit around K40. Speculative decoding usually relies on greedy or very low K drafting. The Tunkenin 3x improvement represents best-case scenarios at K8000, useful for stress tests and certain specialized applications, but unnoticeable for most users' tokens per second metrics. Community response captures the nuance well. I barely use Top K anymore. So many other samplers out there, but it's nice to see. The practical impact is limited, but the engineering approach, recognizing that statistical properties of the data can beat algorithmic complexity guarantees, exemplifies the attention to detail that keeps llama.cpp competitive. At the systems level, Linux 7.0 or 6.20 brings I/O Uring improvements for IO-poll polling. The current implementation manages requests in a singly linked list, deferring completion of request N until all earlier requests complete. For homogeneous I/O, this works fine, but mixed device polling or disparate operations suffer unnecessary delays. The fix, moving to a doubly linked list, enables completing any polled request regardless of queue position. ByteDance's benchmarks show meaningful improvements for production workloads involving diverse I/O patterns. For those building local AI infrastructure, ServeDB v.2.0 offers an offline first vector database targeting edge and air-gapped deployments. The release adds multiple index modes, flat, HNSW, IVF, PQ, with an adaptive auto mode selecting based on system RAM and dataset size. It's not competing with Pinecone or FIAS. It's for developers wanting something small, local, and predictable without cloud dependencies. AI quality assurance and security. Dingo v2.0 addresses a problem that scales with AI adoption: data quality evaluation before bad data poisons models. The open-source tool now supports direct SQL database connections, PostgreSQL, MySQL, Doris, for multi-field quality checks, plus an agent as a judge beta feature leveraging autonomous agents to evaluate hallucination and factual consistency. The feature set targets the full AI data pipeline: pre-training, supervised fine-tuning, and RAG applications. File format flexibility: CSV, Excel, Parquet, JSON, Hugging Face datasets, handles ingestion. End-to-end RAG evaluation assesses retrieval relevance, answer faithfulness, and context alignment. 20-plus heuristic rules combined with LLM-based metrics from GPT-4o and DeepSeek. A visual report dashboard surfaces findings. The Apache 2.0 license and CLI SDK Gradio MCP server integration lower adoption barriers for teams building evaluation into their workflows. MCP security in production environments presents distinct challenges beyond standard endpoint protection. One engineer building a threat model for enterprise MCP deployment found the answer surprisingly simple: authorize based on the origin request. The same model used for every endpoint applies. Anything else creates a confused deputy problem, and mildly doomed understates the risk. Fancy sandboxing and complex permission matrices often just add attack surface. Origin-based auth cuts through the noise while maintaining the security properties that matter. Specialized AI applications. WAN 2.6 targets a specific pain point in AI video generation: multi-shot narrative consistency. The system supports 15-second 1080p HD output, meaningful for showing cause and effect sequences that shorter clips can't accommodate. Reference-guided generation preserves visual identity and voice consistency across shots, enabling single performances or multi-character scenes with synchronized audio. The technical approach addresses common failure modes. Users can upload clips to lock identity or style. Explicit consistency constraints combined with reference guidance maintain character coherence across shots. The recommended workflow is structured: generate with WAN 2.6, score results against a checklist: identity stability, prop continuity, motion realism, lighting consistency, narrative clarity, update one element, regenerate. Testimonials emphasize the shift from repairing random clips to directing, a meaningful distinction for production workflows. GLM ASR Nano brings 1.5B parameter speech recognition optimized for edge cases that standard models handle poorly. Beyond standard Mandarin and English, the model handles Chinese dialects and performs well in extremely low-volume audio scenarios, capturing and transcribing audio that traditional models miss entirely. Benchmarks show the lowest average error rate, 4.10, among comparable open-source models, with particular advantages on Chinese datasets like Wenet meeting, real-world meeting scenarios with noise and overlapping speech, and HL 1. A curiosity for ChatGPT users: the contents of /home OAI skills in ChatGPT's code interpreter environment have been documented and archived. The repository reveals the preloaded capabilities available in OpenAI's execution environment, useful for understanding what tools and frameworks the code interpreter has access to without explicit installation. Development tools and visualization. Brendan Gregg's 2017 comparison of flame graphs, tree maps, and sunburst charts continues circulating among performance engineers, and for good reason. The analysis, using Linux Fort 9 RC5 source files as test data, demonstrates why visualization choice matters for comprehension. Flame graphs, adjacency diagrams with inverted icicle layout, communicate at a glance. Driver's directory appears over 50%, driver's net about 15% of total. Long labeled rectangles allow comparison by length. Small rectangles that are too thin to label also matter less overall. The format works printed on paper or in slide screenshots. Tree maps make comparing sizes slightly more difficult than comparing lengths, though some implementations like Disk Inventory X include labels. The tree list with mini bar graphs for visual comparison helps navigate deep directory structures. Sunbursts, flame graphs in polar coordinates, are very pretty and always wow. But that's precisely the problem. They're the new pie chart. Deeper slices exaggerate their size visually. A slice representing 27.7 megabytes can look smaller than one representing 25.6 megabytes. For data communication rather than aesthetics, rectangular layouts win. In a different corner of technical archaeology, the 39th Chaos Communication Congress featured a deep dive into reverse engineering Roland's JP8000 synthesizer, the digital synth behind Sandstorm and much of 90s trance. The team approached it like video game emulation, decapping chips and mapping logic. When direct connection mapping proved too daunting, they found a simpler device with test mode that, combined with architecture knowledge, revealed the undocumented DSP chip's instruction set. The horrifying answer after all this effort? The legendary supersaw is exactly what it sounds like. 7 sawtooth waves, slightly detuned, layered over each other. No hidden sauce. But the real value was the journey. Recreating the datasheet from first principles for a custom chip and achieving bit-accurate emulation verified against logic analyzer traces. Think MAME, but for synthesizers, though as commenters noted, MAME itself now emulates quite a number of synthesizers with MIDI in-out support.